Okay, so we're going to take a look at graphing linear functions, interpreting the effects of M and B. To recap, M and B, we saw those in our slope-intercept form of the line, where M stood for the slope and B stood for the y-intercept. Okay, so we're going to look at some of the effects of changing those have on situations as well as graphs. It says here, if the slope M is changed, a rate of change in the problem will increase or decrease. Okay? So what we will see is either we'll get a graph of two lines, and we'll notice that one is steeper or less steep, positive, negative, and we can look in the problem situation for something that caused an increase or decrease. Okay? If the y-intercept B is changed, then the initial condition will change. So we'd say like the starting point changed, or how much money we had changed, or something along those lines. It's going to vary problem to problem, so we're just going to have to read carefully. Jackie is on the track team. At practice, she jogs steadily for 400 meters. If Jackie sprinted, which means to run faster, for the entire 400 meters of jogging, how would the graph change? Okay, we got a little typo here. Joanna is really just Jackie, so not really sure what happened there, but I do apologize. Hopefully we can move past that quickly. All right, so Jackie is going to sprint. So if she's running faster, we would think that she would end up at the same point of 400 meters, right, which would be located here on this top line. She would end up at 400 meters, but she would get there sooner. So any point along here would represent her getting there sooner, right, less time. So I'm just going to pick an arbitrary point there, and if we draw to that, right, we can see that our line would be steeper. Okay, this is a steeper line. Okay. If we put our point here, it would still be steeper, but it would be less steep, right? And then if we brought our point over here, still going to be steeper. Okay, so that's just a point I picked, but we could have picked any point, and we would have had the same results. Okay, so now we analyze the situation. The line would begin at a different y-intercept. Well, the y-intercept is 0, 0 distance, 0 time. If she starts running, she's still going to start at 0 distance, 0 time. So the y-intercept is definitely not going to change. The line would not change. Well, I think we've seen the line would definitely change. So it's not B. The line would have a negative slope. A negative slope would be a line going from up here down. And since she's running a distance, her distance is going to be increasing and her time is going to be increasing. So we're not going to get a negative slope. And as we've already said, the line would be steeper. So D is the best answer choice. Josh fills a swimming pool at the rate of 2,000 gallons per hour. There were 3,000 gallons of water in the pool when he started filling it. The total number of gallons of water in the pool after Josh fills it for X hours can be represented by the equation y equals 2,000x plus 3,000. Okay, let's just stop there for a moment and pull these things together. This is a nice, lovely equation, but where did it come from? Let's see. 2,000 is in front of x, which means it's our slope. If it's our slope, it's our rate. And right here, we're talking about a rate of 2,000 gallons per hour. Okay, so that makes sense. And then 3,000 is being added to our x term, and that means it's our y-intercept, and our y-intercept represents our starting amount, or the original value. And it says there were 3,000 gallons when he started. Okay, so that equation makes sense, and x represents the hours. Okay, so if it was 1 hour, then he had 2,000 gallons in that 1 hour, plus the 3,000. All right, I got the equation. Now let's move on. If Josh adds a second hose, he can fill up the pool A twice as, oh, that A doesn't need to be there. Let's take that out. That doesn't make grammar sense there. Okay, so if Josh adds a second hose, he can fill up the pool twice as fast. Which equation can be used to determine the how much faster, oh, that the shouldn't be there either. Okay, which equation can be used to determine how much faster the pool will fill after adding the second hose? Okay, so let's think about this. If it's twice as fast, that's, fast is the rate, okay? So rate of 2,000, if we go twice that, that means 2 times that 2,000. That means my new rate would be 4,000. And I see 4,000 here, and it's with X, which means it's my rate. And then that's the only change I made, was that it was twice as fast. So my starting of 3,000 gallons didn't change. So G is the only answer choice that makes sense. And as I look at these other choices, it's kind of like they just started throwing numbers around. So if you're paying attention and you remember to apply what you know about rates and where it's located in the equation, this shouldn't be a terribly difficult answer to suss out. Okay, let's take a look at another problem. A company's earnings in thousands, Y, after X months this year are modeled by Y equals 50X minus 40. What will the earnings be after 4 months if the slope is halved but the Y-intercept does not change? Okay, so the Y-intercept does not change, so that minus 40 is staying put. The number with X is my slope, and it's going to be halved. To halve something means I'm going to have to divide it in half, right? Divide by 2. So my new equation would be Y equals 25X minus 40. But they didn't ask about my new equation. They said, what will the earnings be? So Y is my earnings in thousands. After X months, and X is going to be 4 because I want to know after 4 months. So my earnings Y after 4 months, got a little happy with my lines there, minus 40. So that would be my earnings Y would be 100 minus 40. So Y would be 60, but Y is in thousands, so my answer would be 60,000, which is answer choice A. Yay, go us, we found it. All right, you should now be ready to take on graphing linear function 6. Just be careful, think it through, read, do some of the things like I was doing, underline, highlight, take it slow and easy. They're not particularly difficult, but you do have to read carefully.